Welcome back, engineers. So far, we have discussed so many topics in system design. We have discussed the core topics, we have discussed the numbers, we have discussed different techniques used in system design, the common ones. We have discussed architectural styles, how to choose an architectural style. We have also discussed common trade-offs in system design, right? In this section, I'm going to start talking about architecture risk, which is quite often overlooked by many system design series videos. And I think it is very important to understand what is a risk in any system design and how to identify it, how to identify the severity of it, how to identify the mitigation points of it, and how to actually do this whole exercise of identifying architecture risk, right? So in this section, let's try to build the framework for identifying and working with architecture risk, and we will do a couple of videos where we will take an example of a real system architecture and try to identify the risks involved in that architecture, right? I hope you're ready. Let's get started. So in this video, let's try to understand the fundamentals. What is the risk, how to do risk analysis, what is the framework involved in doing this risk analysis and all that, right? So let's try to understand this with the help of a small story so that it is easier to understand, right? So let's say there are a couple of friends who have decided to go on a trek over a big mountain range. So this is the mountain range, there is a hilltop, this is where they are trying to reach. So they planned the whole trip and they have started their journey. They're very excited to go to the top of the mountain range, right? But there is one thing that they have not accounted for in their plan, that is the rainfall. So if you can see here, there are a couple of clouds moving from the east side to the west side towards the mountain range. And let's say as they're going along their trek, the clouds are slowly coming towards the mountain range, and eventually, as you can imagine, there is going to be heavy rainfall, right? So there's going to be heavy rainfall, and this is going to disrupt their whole plan, right? So they might get stuck somewhere, they might get injured due to slippery mountain range, they might get departed from each other and all that. So there is an element of weather that is creating an impact, or that is creating a disturbance in their plan to the trek, right? So a lot of things have happened in this little story. So there was a trek, there were a couple of friends, multiple people involved, and there was a plan to go on top of the mountain. The weather was involved, and the weather disturbed their plan, and now they have to recreate their plan and do some additional planning and so on, right? So there are a bunch of things happening here. Now let's try to break down this story and understand what is the risk, right? So the uncertainty in this story was the weather, right? So they didn't account for the weather, they didn't see the weather application, they didn't see the weather updates, and they just went about on their trek, right? So this is the uncertainty. Weather can be good, weather can be bad, right? And the event that has disturbed them is heavy rain, right? So heavy rain on a mountain range is actually quite risky, right? And because of this heavy rain, there could be injury and they could have been stranded on a mountain range, right? So this is a consequence. So there is uncertainty, there is event, and there is consequence, right? So we don't know if this event will happen, but we know that because of the uncertain weather conditions, it might happen, right? So the risk involved here is the weather. This uncertain thing is called risk. We don't know whether it will happen or not, but there is a chance that this can create a disturbance or an impact on our plan, right? So that is what a risk is about. So at this point, you might be thinking, everything is a risk then, weather is a risk, my shoes are a risk, maybe my mobile network goes down, that is a risk, maybe the mountain range is too steep, maybe there are animals on the mountain, everything is a risk. If everything is a risk, then nobody will plan to go anywhere, and there is nothing happening around the world, right? But that's not the case. Everything is a risk. There are many risks involved in any plan, but the likelihood of occurrence is a key factor here. So if they have checked the weather update and the weather update said it's bright sunny day, then the likelihood of a heavy rain is minimal. Then the risk becomes low risk. If they have checked the weather app and the weather app said it is going to be a heavy rainfall with thunderstorms, then the likelihood of at least seeing a rain is very high. Then that becomes a high risk, right? So there is low risk, there is medium risk, and then there is high risk. The art is in identifying the risk for sure, but also the likelihood of their occurrence, right? So that is how a risk matrix was defined, and this is how it works, right? So let me close this. So this is how the risk matrix looks like. So there is a likelihood of occurrence of a risk, low, medium, high, and then there is the impact of the risk, low, medium, high, right? So on the left side we have the impact, and on top we have likelihood of occurrence, right? So if something has low impact and low likelihood of occurrence, we'll put it here. And if something has high impact and high likelihood of occurrence, we'll put it here, right? That's why it is on the high range. So the way to calculate these numbers is just using multiplication. 1 into 1 comes 1, 1 into 2 is 2, 1 into 3 is 3, and so on. That's how we build this matrix. And the numbers 1, 2 are, in the green zone, which means they're okay. We can actually safely ignore them. The ones in the medium are something we need to address them, and something in red are something we definitely have to address, look into it closely, and have a mitigation plan for sure, right? So this is how the risk matrix is defined. Let's try to understand this matrix using an example. So let's say we want to do availability risk. What is the availability risk in my system design? So the question we are asking is, what if my primary database goes down, right? So for this also we can use this concept, uncertainty, event, and consequence. So what is the uncertainty here? Uncertainty is database might go down due to, let's say, a network issue, or maybe a cable is cut, or maybe bad weather in the data center, and so on. There can be so many different uncertainties in a system design. And what is the event? Event is database is down, DB is down. And what is the consequence? Because of my database is down, and because that is a primary database, my application is not usable. Application unusable. So because the application is unusable, my users cannot access it, my business is impacted, I'm going to put it as a high in impact zone, right? So it is going to be a high impact item for me. But let's try to analyze the likelihood of occurrence as well. So what is the likelihood of a network outage in a data center? What is the likelihood of a cable being cut, or having a very bad weather in a data center, right? So the likelihood of all that happening, let's say, is very low, right? Let's say is very low. In that case, my risk matrix, we will mark it as low likelihood of occurrence and high impact. So the risk score comes out to be 3, which is a medium risk, which means we have to try to mitigate it. Maybe we will add some more data centers. Maybe we will add couple more databases for replication sets, and if one primary database goes down, the secondary database can kick in, which reduces the impact even further. Maybe it will bring down the risk to low as well, right? Then it becomes low impact, low likelihood, right? That's how we can do risk analysis, right? So we can build the risk score for ilities like this: availability, security, scalability, and so on. But we can also build it at a feature level and build out a big risk assessment matrix for everything in my system architecture. So it looks something like this. So this is the risk assessment table for the entire architecture. Let's say we are taking an example of a commerce application which has registration, checkout, and shipment as the main feature sets, and we are doing the risk assessment across different ilities: scalability, availability, performance, security, and data integrity. And for each of them, we have analyzed the risk based on impact and likelihood of occurrence, and we got these scores, right? So if you build out a matrix like this, we can actually analyze which is the area that is giving me more risk. So you can see the totals here: 24, 21, 11. We know that registration has some significant risk compared to others, and similarly at a ility level as well, we can see that data integrity is having some significant risk, right? So at this point of time, we can choose: should we ignore the low risks? We can definitely eliminate them. Let me eliminate the low risk items. So low risk items are gone now. Maybe we also choose to eliminate the medium risk items. We're not worried about them. Now we can only look at the very high risk items, and we definitely have to look into them. And once you're sorted with this, then probably we can look at the medium level items as well, right? So how to build this matrix, how to do this whole table for a particular architecture, how to take an architecture and come to this point is something we will see with some examples in the upcoming videos. But for now, the takeaway is that there is a risk matrix that we can use, which has impact and likelihood of occurrence, which gives out a risk score against which we can build out risk assessment for our architecture, right? So that's a quick introduction to architecture risk, guys. In the next video, we will have a look at our architecture and we will do this exercise about risk storming. right? I'll see you there. Thank you so much for watching. Please leave a like if you found this helpful. Please subscribe if you haven't done already. I'll see you in the next one. Cheers.